Hey, I'm going to show you how to get started with Sim IDX, which is Dune's new end-to-end indexing layer for on-chain apps. You can think about IDX as sort of the next generation of indexing tools, and it works similar to like a Ponder or a Subgraph, but it's pretty incredible in terms of capabilities and performance. So you just go to sim.dune.idx to learn more. We also have pretty extensive docs. But this video is just going to take you through what it looks like. So within the Sim developer portal, we can essentially just click Create App. And the first time you do this, we ask you to essentially connect your GitHub account. I'm going to get started with an empty repo, and I'm going to call this Uniswap Factories. And then I'm going to give this one just the same name. Okay, so what happened now? First of all, we created an empty repository on GitHub, and we have what seems like an empty IDX app. I'm going to go ahead and I'm going to clone this repo, git clone. And I'm going to run sim init. Now, sim init, I'm going to show you in a second when it's done, essentially generates a bunch of code, and it does your first initial commit for you. So just push this and go to GitHub, refresh, and you can see that I have now a repository actually. So Sim init essentially creates a sample project for you. It indexes factory pool creations and creates an API on top of it. So I just pushed this repository, so let's have a look at what happens on the IDX side. So on the IDX side, essentially we listen to your GitHub repo, and whenever there's a new commit in main, we start building a production environment deployment. Whenever there's a PR, we start building a preview deployment. So in this case, there's already a deployment that's in the backfilling stage, and it's the one we just deployed. And you can see sort of some metadata about it. We've essentially backfilled all of Unichain, most of Ethereum, we're backfilling others. So a deployment like this actually gives you a database URL that you can connect to. And you should treat this database as fully managed by Sim, so you don't have create permissions or anything. The framework does that. And I can do select star from pool created. And we have a bunch of data in here. And I can click one of these API routes, and you can see that we have an API that is essentially giving us pools along with data. Now, how did this happen? So let's go back to Cursor. Sim IDX essentially has two concepts that users need to know about. One is the APIs, and that's the simple part. APIs is essentially how you define these API endpoints. And in IDX, these are simply Hono endpoints. So we're essentially just doing a database query and returning it. But you can do arbitrarily sort of complicated things here, and behind the scenes, we actually provision and deploy your API on globally replicated infrastructure. We take care of actually generating all the types that you need here. So they're generated from the index that you create. This is very simple to work with. Now, what is the other concept? The other concept, the one that we're going to spend a little bit more time on, is listeners. The listeners folder in IDX is essentially a complete Foundry project. So you can run familiar Foundry commands, and you can create tests that you can run, and you essentially work from this main.solve file. If I go now to here and I run sim test, essentially we're running Foundry tests. In main.sol, there are two contracts that we already have defined. One is your trigger contract, which implements the base triggers interface. And the other one is your listener contract. So I'm going to just quickly talk about the trigger contract first because it's so simple. The trigger contract just hooks up your listener to whatever you want to listen to. In this case, our listener is implementing the onCreate pool. And so essentially every row or every line of code you see here is just hooking up our listener contract to a contract. So we're saying call our listener contract on Ethereum on this address, on Unichain on this address, on Base on this address. This is pretty flexible. You can listen to an ABI, you can listen to a specific contract, you can do for loop, you can do anything. It's just Solidity essentially. And what we're going to look at now is the listener. And the listener is where the interesting thing is. So the listener works essentially in the following way. You define your contract and you implement some interface. This interface is telling our framework essentially what is the on-chain action that I want to react to. In this case, it's I want to react to whenever the create pool function is called on some contract. So in this case, this function will be called every time that happens. I've defined an event. This event is this is essentially your database schema. This is how we emit data from within the EVM to the Postgres database, which you can then use in your API. And this is very flexible. There's no sort of issue with changing this. I'll show you on the fly here how we change it. Just going to delete this test because I'm going to change a lot here. Some test. And so I've now essentially changed this listener to remove the fee. So if I go to Etherscan for a quick second on this contract, I'm just going to find a block where a contract is created. So pick this block. 4 minutes ago, a pool was created. I'm going to do sim listeners evaluate. What this is going to do is, what this is going to do is essentially just compile our listener contract and run it on this block, on this chain. And you can see that there's no fee here. If I go back to my main.sol and I take the fee back into the event and evaluate this listener again, you should see that the fee now appears. Okay, so what we're going to do now is just quickly create a PR that adds some more logic. So if you look at these pools, they have the following data: chain ID, caller, pool, token 0, token 1, and fee. And let's say I just want more information about these tokens. In a normal sort of indexing paradigm, I would need to do ETH calls in order to figure out the symbol and the decimals of these tokens. But in Sim IDX, we're essentially executing this from within the EVM, so we can do more clever things. So I'm just going to create a new file, call it ierc20.sol. I'm going to ask cursor to add ERC20 interface here because I'm too lazy to look it up. This one is more than we need. Let's see, add name, decimals, symbol interface for ERC20. Accept this. I'm going to import it, and now I'm going to enrich my event. First, I'm going to format, and I'm going to start adding here token name, symbol, and decimals for token 0 and for token 1. And I'm going to exactly this instantiate 2 ERC20 tokens using this interface. and just going to call functions on these contracts. Very, very simple to now enrich with token metadata. Now I'm going to run listeners evaluate. And we can see that we've essentially enriched our pool created events with token metadata. To show you how IDX works, I'm going to create a new branch. I'm going to add all of this to this branch. And I'm going to push it essentially to this branch. I'm going to go to this URL and create a PR. So you can see that this PR adds the interface, changes the formatting, but also just makes this pool created event enriched. Now let's go to IDX, and if I refresh here, you can see that we have one production deployment that is essentially building and ingesting. This is the one we looked at before. Unichain ready. We're still backfilling base. There's a lot of blocks. Ethereum is essentially complete. But we also have this preview deployment that's going on. And you can see that we're ingesting this as well. And if I now go to this URL, you can see that we now have an API with enriched token data. So these are the basic concepts of Sim IDX, and I'll be back with more complicated stuff in the future.